Welcome to my Cisco's Routing Essentials lab review. Tonight we're doing lab 7224, comparing RIP and EIGRP path selection. So I have my instructions, I have my packet tracer open. So let's go through some of these questions. So predict the path. So step 1, EIGRP can consider many different metrics, but by default, however, bandwidth and delay are the most used commonly selections. So based on this metric, what path would you predict the data would take from PC-A to PC-B? With that said, it should go PC-A to RA, the router, to R1, R2, R3, RB, PCB. Because again, here the metric is bandwidth. 4 megabits, 4 megabits, 100 megabits, 100 megabits, as opposed to 1.2 kilobits all the way through. So that's with the EIGRP, it'd take the top route. Step 2, consider RIP. What metric does RIP use? RIP uses hop count. So based on this metric, what would the path be? Well, there are fewer hops on the bottom route. So PCA, RA, R4, R5, RB, PCB. Because again, there are only 1, 2, 3 hop counts here, as opposed to 1, 2, 3, 4 on the very top. So different metrics will choose different paths. So do make sure that you understand that. So let's go ahead and go to part 2. So on RA, let's go ahead and let's look at the routing table. Enable, show IP route. A lot of directly connected routes, 3, and a lot of these D. What is D? D stands for EIGRP. So let's go ahead and let's do a trace route from A to B. So I'm going to hop on PCA, go to my command prompt, trace RT, and of course I don't know the IP address of PCB. I'll just kind of fix that window, ipconfig. Alright, so I want to trace route 64.103.0.1, and it took 1, 2, 3, 4 hops. It should have taken the top pathway, because again, we're using EIGRP. So it should go 64, 100, 0, 255, then to 02, then 06, 010, 14, and then 1. How many hops away is it? 5 hops. What is the minimum bandwidth of the path? We do the very top one, 100, 4, 4, and 100. The minimum is 4 megabits per second. Alright, so I'm going to move these out the way. I scrolled down too far. So let's start examining the router or the RIP version 2 paths. For references only, let's show the routing table on RA. Again, show IP route, just so that we have a good understanding of the way that it's working. So what's the first number between the brackets in each EIGRP? That's going to be our metric. Our metric is 90, because with EIGRP, the metric normally is 90. So we're going to configure router RIP to use a different distance. So let's get to our configuration mode. So config T. Let's go ahead and do router RIP. Distance, we're going to set to 89. We're going to wait a few minutes. And I want to do my show IP route again. You notice that now the routing table is using router RIP and no longer EIGRP. Both were set up, but it's going to use the lowest metric to determine which is going to be the best path. So we manually set router RIP to a lower distance, so it's going to use that. So let's go ahead, bring back my Windows terminals. Let's go ahead and ping again from A to B. Notice it took a different path. 2, 6, 14, then 1. Well, it didn't go to 10. Alright, that was kind of weird, because that's still the top path, it just didn't actually show everything. Alright, I'm going to give this a few minutes just to make sure. And that's right, it should go 256, 2, 4, 14. That's 4 hops away. 1, 2, 3, 4. 1, 2, 3. So it did not go this route. What's really weird is minimum path bandwidth using RIP. If we were to go the bottom route, it'd be 1.2 kilobits per second. What is our metric? We hard set it to 89. So we're done with these guys. Let's look at these questions right down here. What metric does RIP version 2 use? It ignores everything but hops. What could this affect in performance? Well, RIP will ignore a faster bandwidth pass for less hops. EIGRP will ignore hops. EIGRP prefers things like bandwidth and reliability. It doesn't care about hops. How could this affect performance? It is conceivable that a packet could be dropped if it travels more than the time to live. So if it's too many hops away, it could die. Going on to question 3, which do you prefer within your own internet access? Lower hops or more bandwidth? Honestly, I'm all for bandwidth. Step 4, or question 4, is one routing protocol suitable for all applications? No. They all have the characteristics, and they're all best in their own specific circumstances. It's understanding the characteristics so you know when to use which routing protocol. And that's actually the end of this lab. I want to thank you.